If you know the graph of f of x, then you can get the graph of negative f of x by reflecting f of x across the x-axis, and you can get the graph of f of negative x by reflecting f of x across the y-axis. Example, semi-parabola, f of x equals square root of x. Semi-parabola, if you g of x equals negative square root of negative x. Here we want to reflect it across the y-axis and across the x-axis, so we reflect it twice. And this is the new semi-parabola. G of x equal minus square root of x. Here we're only reflecting it once. We reflect it across the x-axis, and this is our new graph. And g of x equals square root of minus x. Here we're reflecting it across the y-axis. Semicircle, f of x equals square root of 1 minus x squared. So the original graph is a semicircle. If you replace x by negative x, well, negative x, if you square negative x, you get the same thing as you squaring x, right? So it's not going to change. So you actually end up with the same graph. In fact, you can tell from the picture, replacing x by negative x should flip it across the y-axis. But if you flip if you look at the graph here, the left side is a mirror image of the right side. So flipping across the y-axis gives you back the same semicircle. If the minus sign is on the outside, you're changing the sign of the outputs. G of x equals negative square root of 1 minus x squared. Now you're flipping it across the x-axis. So now you have a change. And there's some terminology about functions that are not changed by certain kinds of reflections. Functions such as f of x equals square root of 1 minus x squared are called even functions, and they have the property that f of minus x is equal to f of x. And thus reflecting the graph about the y-axis does not change the graph. Even functions are said to be symmetric with respect to the y-axis. Often, but not always, even functions have even powers of x. Functions such as f of x equal x cubed are called odd functions, and they have the property that f of minus x is equal to minus f of x. And thus reflecting the graph about the x-axis has the same effect as reflecting the graph across the y-axis. Odd functions are said to be symmetric with respect to the origin, because rotating the function 180 degrees about the origin results in the same function. Often, but not always, odd functions have odd powers of x. Here's some examples of functions that are neither even nor odd. F of x equals square root of x is neither even nor odd. F of x equals x cubed plus x squared is neither even nor odd. Function f of x equals 0 is both even and odd. And that concludes this presentation.